welcome to another edition of Easy Theory. We're going to do an example now of showing that A avoids B is regular, where A and B are regular. So what we were able to show is that the avoids property, which is all the strings in A that don't have any string in B as a substring, that language is regular. And what we were able to do is we were able to phrase it in this terminology right here. We take all the strings that are substrings of B and also in A. So those are all the strings in A that do have something in B as a substring, and take away all of those from A. So then what we're left with is the ones that don't have any substring as something in B. Okay, so let's actually do an example here. So as always, these examples are not cooked up. I am doing this completely live. So let's say, for example, that we have A being, I don't know. So how about all the strings that start and end with a 0? So W in 0, 1 star, such that W starts and ends with a 0. Okay, so then let's just do an example of having B being 1 star. So that means B is all the strings that happen to have 1s. So what we should expect for A avoids B, I think, so this says that B has all the strings with only 1s in them. So then that means that A avoids B shouldn't have any string with 1s in it at all. So that's what we should expect. But let's actually carry this out. So let's actually try to build a machine for this entire thing and then see what we actually get. So the sigma star B sigma star is the same thing as sigma star 1 star sigma star. So then if we make a simple little machine to do this, so sigma here is 0 and 1. And then I'm just going to do this. Actually, no, it's not a final state. So then here we're going to take a epsilon transition over to here. Actually, I'm going to amend the example. I'm going to have it be 1 plus. Because if I have the empty string in there, then A avoids B is not going to have any strings at all, because the empty string is a substring of everything. So I'm going to have this be 1 plus. So if you don't recall or know what this is, 1 plus just means all the strings that consist of 1s, but have at least one occurrence of 1, so excluding the empty string. So what I'm going to do here is to satisfy the 1 plus right here, what I'm going to do is to have a 1 right here. So this is just a really simple machine. So it just means that the string happens to contain a 1. Okay, so now let's actually carry this out right here. So, and also, so now we need to actually make a machine for A. So I'm going to make a DFA for it. So let's see, so it starts and ends with a 0. So if it's, the question is starts and ends with a 0. I'm assuming that means it doesn't have the empty string in there. So I'm not going to accept the empty string. So if it starts with a 1, then that means we should go to a dead state here. If it contains a 0, then we'll go to a state right here, which it should be final, because the string with just one occurrence of 0 should be accepted. But if I have more 0s, I should be here. If I have 1s, then I should go over to here and then back on 1. So this is like the machine that we've done before several times, where if it starts with a 0, then I'll go over, oops, I have this backwards. So this should be 1, this should be 0. So this is just saying that among these two, if you read a 0, you end up here. If you read a 1, you end up here. And yeah, that's the best I can do for that. So what about a DFA for this one? So let's actually make a DFA for this. So let's see. So then if we have this start state, if you see a 0, you stay there. If you have a 1, I'm going to call this Q0, Q1. So then that means I could be in Q0 or Q1. And okay, yeah. So in fact, I don't even need the state names here. So yeah, I should do this instead. Yeah, because if I see a 1, then I'm going to accept anyway. Okay, so now what it says to do is to do the intersection of the two. And the best way I know how to do that is with the product construction. So I'm going to label the states as Q0, Q1, Q2, Q3, R0, R1. Okay, so then now let's start making the machine. So the start state is going to be Q0, R0. And then if I see a 1, then it's doing intersection. So then that means that I'm going to end up in a dead state no matter what. So this machine doesn't matter what it does. So if I see a 1, then I'm going to go to a dead state. Note that this is not exactly the product construction. I'm doing this purely for time reasons in our sanity. So if I see a 0 here, then I'm going to go to, let's see, so that'd be Q1 R0. So then if I see a 0 from Q1, then I'm going to be in Q1. So this one's going to loop on 0 from what I can tell. If I see a 1, where do I go? I go to Q3 R1. So then Q3 R1 on 1. If I do this one on 0, where do I go? I go back to Q1, R1 goes to itself. So then that means I go to Q1, R1. If I take this guy on 1, then that means, let's see, Q3 goes to itself, R1 goes to itself. So I'm going to self loop on this one, which is good. Q1, R1, it loops on 0 from both of them, from what I can tell. On 1, where do I go? Q1. So Q1 goes to Q3, R1 goes to itself. So I'm going to go back to here on 1, thankfully. And then now the final states, the only one would be Q1, R1. Yeah. Yeah, that should be right. Oops. Zoomed in there. So that means that it must include a 1? Yeah, okay, yeah, that's right. So at this point right here, this is all the strings in A, so that means it starts and ends with the 0, that do contain something from B, which means it must have at least one occurrence of 1, which is nice to see here. And I don't think I can simplify this machine any further. So what we need to do now is to do this part right here, which is to take A and intersect it with the complement of this thing. So what I'm going to do here is I'm going to complement this, paste, and I'm going to change the color to be red. And I'm going to invert all of the final states. So every other state is going to be final here. Yeah, so the only one that's not final is this one now. So then now let's copy the machine for A back so that we can, oh boy, do the product construction on these two. So I'm going to paste. Let's see, have it all fit. So I'm gonna keep these state names the same. I'm gonna change these ones over here so that I don't have like multiple occurrences of Q0 and R1 and whatever. So I'm gonna label these in green to be not Q, R0, R1, R2, R3, R4. And we're doing the intersection this time. So let's start. Oh boy. Let's do it in pink. So Q0, R0 is the start state. If I see a 0, where am I going to go? I'm going to go to R2, Q1s. So Q1, R2, that's the state. If I take a 1 from here, where do I go? I go to R1, Q2. Okay, yeah, so this one closes up nicely. So Q2, R1, and this will self-loop on everything. And this one should not be a final state because this one's not final. And that means it started with a 1, therefore we shouldn't accept. So that's good so far. Q1, R2. So on 0, where do we go? So Q1 goes to itself. R2 goes to itself. So this will self-loop on 0. What about on 1? Where does it go? So Q1 on 1 will go to Q3. R2 will go to R3. So it'll be Q3, R3, from what I can tell. So then Q3, R3, where does it go on? Let's actually just check that to be sure. So R2 goes to R3, Q1 goes to Q3 on 1. Yeah. So then Q3 on 0, it goes to Q1, R3 goes to R4. So Q1, R4. And then on 1, where do we go? Q3 goes to itself, R3 goes to itself. So this should be a self loop. And then let's see, Q1, R4, where do we go on 0? Q1 goes to itself, R4 goes to itself. That's always good to see. It's nice to do the product construction when you're building states up like this, so you don't have to do the entire product here. It's the same thing as the NFA to DFA conversion. But anyway, so Q1, R4 on 1. So Q1 goes to Q3, R4 goes to R3. So in fact, it goes back to Q3, R3, which is good. And then now the moment of truth. Hopefully I didn't make a mistake. So now the final states are going to be the ones that are the intersection. So that means that it must have a Q1 in it. And so this one is not final. Is that right? Yeah, that's right. Q2, R1. Yeah, so neither of these two is final, which is good. That's exactly what we would want. So then, yeah. So then for this one right here, Q1, R2, is that final? Yep. So as it should be. And then Q3, R3, nope. Q1, R4, nope. Okay, good. So in fact, we get this machine right here, and we can verify that it's correct because if we think about it, we must have at least 1 0 because it must start and end with a 0, so it must have at least 1 0, and it can't have a 1 from what we predicted. So if it has a 1, well, that means it either started with a 1, which means we never accept, or we're over here in this state and we see a 1 at some point, which means we go to one of these two states, but neither one of them is final, which means we'll never accept anyway. So the only strings that are accepted are the strings of just zeros and have at least one occurrence of 0. So that's a verification that this actually does work in this case. So I hope that was interesting. If you have any other interesting examples, put them in the comments. As always, please like and subscribe to the channel. It really helps us out with the growth of the channel. And if you comment, that also really helps a lot more. And as always, I'll see you next time.